in 2009, I started working at a company called TextTalk. They were building this hosted webshop solution that they had been building since the late 90s. It was converted from Perl line by line to PHP and was now hosting about 2,000 webshops on a PHP Apache server and a Postgres standing in the office. So I joined a team of about 4 developers with a few others coming in from time to time. And the code repository was, the code was on a development server, copied file by file or directory over to the production server, and the development was done on local machines, and we copied it to the development machine to stage it and try it out. And it failed a lot. I mean, it might have worked well when there was 1 or 2 developers, but with 4 developers and some other of the seniors in the company coming in and fixing things, you copied a directory to your local computer, you changed things, you copied the directory back to the development server, hoping that no one else was working in the same directory, and files got missing, and you couldn't really see how the files looked a week earlier unless you went to the ops guys and asked, oh, can you restore this tar backup from the hard drive you took out last week? And things failing in production like got you into panic because you couldn't back up into the previous version. Getting a backup was too far a process. So obviously after a while we went over to Git. I had been working with the version control system since the 90s, so I was a bit astonished about how they handled their code. But we went over to Git, and what Git does is that from the initiation of a repository, instead of storing the current state, it stores every change you have made to that state. It stores when you did it, who did it, and why they did it. So what you can see in a Git commit, well, why they did it is often like something like updated this thing or changed something. But it at least stores some kind of purpose with the change. And in a backend context for storing data, we would call this event sourcing. So instead of storing the current state, you store every change that has happened as a separate event. And one Git commit is one event. And Git doesn't store the current state at all. In the Git repository, it just stores everything that happened, like a long log of changes. And from that log of changes, you can check out code, and the checkout gives you the current state of the code base. But you can also do other things with it. You can see how many lines of code has a certain developer added this week if you want to base your pay on that. Don't do that. And you can see, like, when did this line come in? Oh, and we can even see that these 2 last lines, they were added a month in the next month, and it's actually switched to daylight savings times as well. You can annotate the code. You can see, you can draw a lot of conclusions from this log of events that you could never do from the current state. You can back up to a previous, you can revert. You can add a revert that just goes back to a previous version, just because you do this event sourcing instead of storing the current state. I would be very surprised to find any company that just stores their code repository in the current state without having a version control system. But for some reason, I still see companies storing their business data in just the current state, updating a SQL row and losing valuable data. And sometimes later they realize that, oh, it would have been good to know what happened there, why this was updated, who did this. And you come into a state where you have backend data that you can't understand. How could it possibly become this way? And you can never know because you don't have all the change events. So let's look at a few practices when it comes to event sourcing. We have an event stream that is categorized as a comment with an ID. So instead of having a comments table with rows that has their IDs. We have a stream for each comment. And for every event that comes in, we have a type of the event, which is here they commented, and then we have another event for edited comments. We have a revision that always starts at 0 and always has every number after it, because that's how we have a concurrency. I will mention that more later. We always know when the event came in, and by best practices, we always store who did it, because it could have been an administrator or someone else that initiated this event. So like when someone edited the comment, maybe it was the product owner or something. But we also have the event data that is specific to the type of the event. So for the commented event, you can see on which product did they comment. But that data is not needed in the edited comment, because when you edit a comment, you don't move it to a different product. And it's even more clear on a deleted. You don't have any event-specific data. You only have the standard by, at, and revision number. So how do we use this data? We can't really do a checkout on this. But just like git checkout does, we aggregate it into a current state. So like we have the command handler that takes a request from a user. Yeah, I want to comment on this. And it forms an event, puts it into the event store, and then we have an aggregator listening to every event that comes in, or reads all the historical events, and aggregates the current state as we want to see it most of the time. And the aggregator could keep it in memory unless you have terabytes of data, of course. The aggregator could also have an HTTP interface to answer questions, answer a GET comment with that ID, and then it just outputs the data that it has aggregated. And we can have multiple listeners to that. But let's see a bit of a practical example. Like in functional programming, we call it reduce. When you have a list of events from a certain comment stream, we reduce them into what the comment state is now. And the only thing the reducer needs to know is, so what is the current state? That's the comment now. And the event that came in. And then for the commented event, okay, we want to keep the current state. This is modern JavaScript for people who don't code that. We keep the current state with a dot comment. That's an object spread. And then we add a created at, because commented should be the first event in the stream. And we add the author and the body. But then for the edited and for the deleted, we don't add the created at, but we add an updated at. We replace the body with the new body. And with that simple code, we can just reduce any event stream into the current state of what we want to do. You see my pointer. So, but yeah, if you have a lot of gigabytes of data, we store it. So we have the aggregator listening to every event that comes in and stores it in some kind of projection store. And we call it a projection because regardless of how you want to aggregate this data, it is always some kind of projection. It is not the full event stream, because only the event stream is the single source of truth. So I have a projection store, and in the projection store that could be a SQL database, it could be a document database, and the aggregator could check the current state from the projection store, and when a new event comes in, if there are too many comments, like it comes in an event on ABC123 comments, it checks in the projection store what's the current state, adds the event to that, and puts it back into the projection store. And if you want to change how you represent this data, you can just do a change in the aggregator and let it reread from the beginning of history. And it's actually much quicker than you would imagine to do that. And that's exactly what Git does. You can check out a big repository, check out a new branch, and it aggregates the current state from a lot of commits in a matter of seconds normally. But one important thing here is that the projection store can never deny what happened. So an event that is stored in the event store, that is something that happened. That's also why we always have a past tense verb of the event. It's commented. This already happened. If it's been accepted by the event store, it happened. So you cannot have a SQL database with references to other tables that would say, no, we have a reference error, we won't store this comment. But it happened. So then you have a problem in your database. You don't have a problem in the event stream. Which is why most of the time you would prefer using a document database for this, because you end up with a document formatted like you would like to use it in the API or in the front end. But you can always have multiple read sites. You can have a specialized read site that can just answer, oh, give me a list of all comments on this product. So that's not an aggregation of one comment stream. It's an aggregation of all comment streams. That listens to all the comment streams and sorts them into each product. Instead of having a SQL database where you do a select by product or have special indexes, you can have specialized aggregations or projections of it. You can also have a read side from the projection store that is just a small function that takes a GET request and feeds out the current state. But separating the command handler and the query side of the data and segregating them properly, that's what is called CQRS. So Greg Young introduced this concept of command query responsibility segregation. There was already a good practice that was called command query separation that led to these classes having a getter and a setter. And the setter would never return the data, but you would have to ask the getter for that. But in this case, you segregate it completely. You have it in different places of the code. Maybe different classes, maybe different services. And I would argue that in most cases, you would like to have them in different services. Because to separate fully, you have them in small services that are specialized for what they do. If you find a bug in the state or in the aggregator, you just make a new aggregator. It starts up, it reads all the history that happened, and gets the state up to date with what is currently the format we want to use. You can just spin up a modified version of that aggregator if you want a new state. Oh, now I want the version 2 of this endpoint. Yeah, okay. We spin up that, and we have that routed by the API gateway into that aggregator instead. So that's why the microservices are the aggregators or the services that keep running, that keep a state up to date in memory. The serverless is the fancy buzzword for functions, that we don't care about how the functions are called. So in Google Cloud, it's called Cloud Functions. In AWS, it's called Lambdas. And most of the time, they are probably run just like you would run the function in Node that's with Express.js. But you don't have to care about that part of the code. So the developer just pushes up the exact handler for that request, for an HTTP request or for an event coming in, and pushes that to the cloud, and the cloud scales it. It can scale it so, okay, now it's a high demand for these GET queries. Let's have 100 of these side by side. And sure, they need to connect to the event store or to the projection database. But other than that, they have no real overhead. Which means that you can deploy them separately, you can run them separately, they can crash separately. So when one of them crashes, you don't bring down the rest of the application. So let's touch on the concurrency for a few minutes. One big problem with managing huge amount of data, in SQL, for example, you would handle concurrency in a pessimistic way. You say, okay, let's start a transaction and lock up these rows because I'm going to change them now. And then you get the current state of these rows while you lock them. Then you do your changes, and nobody else can touch those rows until you've committed your transaction. And in event sourcing, we do a more optimistic approach. Let's do the changes and send them in. And if they are not accepted, then you get an error message back instead. And the way we do that is by this revision number. So we can do it as far out as the front end. The front end can get a comment and get the revision number with the comment. And the user starts editing that. And the front end sends in, okay, now we have an edited version of this with a new body. And we expect it, we expect the revision number of this stream to be at number 6, because that's what we saw when we got the comment. And in the back end, it might be a function that just appends this to the stream. Okay, we have an edited comment event because the command was edit comment. We have an edit comment event, and the backend adds the timestamp with at, the authorized user with a by, and the body that they sent in. And we expect the revision to be number 6. And what the event store then does is that, no, it's not a number 6, I won't accept this. Precondition failed. And we can send that to the front end. Or this can be purely a backend. It can be a backend that accepts that takes the request from front end, checks the current state, like gets the current state from the aggregator and sees, okay, is this a reasonable change to make? And then it sends it to the event store. But maybe another event has come in while it was doing these checks. So that's why you really want an event store that can handle the optimistic concurrency. And that's a big difference between using a specialized event store, like the event store, unfortunately named event store, that Greg Young made, or using something like a log handler like Kafka. Because in Kafka, you wouldn't get this denial. You would have to build a layer on top of it that handles the revision number and checks the revision number, and you would have be susceptible for race conditions that could be that could cause problems that is much harder to handle than most of the other things that you run into when your code starts scaling. So you want an event store that can count your events, that can handle subscriptions, so that many other services can subscribe to anything that happens in this stream. You want the optimistic concurrency, and you want to have the storing and the event routing in the same service. I have done event sourcing with a combination of RabbitMQ and MySQL, but then you really need to all of the time you need to bounce these back and forth and handle the concurrency. And then if you have a specialized event store, you also get category projections, which means that when you send in an event to comment ABC123, it also has the category comments stream where you can get all the comment events from all the different streams. And that's very useful. So, as long as you update your main source of truth, you are losing valuable data. That's my argument today. Any questions? Yes?
How's the tooling around the event stores? Because I have seen like that when working with graph databases that you don't have something like PyMyAdmin or whatever is MySQL's kind of interfaces and so on.
Yeah, so if you take event store, for example, then it comes with the user interface where you can see all the streams. You can see the recent stream. You can add an event to a stream. But to make a projection, you still want to probably write a small snippet instead and run it locally. But you can see the streams and the things that are coming into the stream. So when you start out, it can be very handy to go into that user interface and see, does my event actually reach here, and does it get projected to the category stream? But I think the tooling is fair enough.
the aggregator that builds the aggregates, does it always pull, or is it pull and push, or how do you keep the aggregates up to date?
If you have it as a service, then it gets events pushed to it. So Event Store, for example, works with a gRPC connection. So you have a TCP connection open to the Event Store, subscribing to all the new events. You can also subscribe to events and have a pointer, like a registered subscription, so that if your aggregator goes down and you bring it up again, it can take up where it left off. And you can also have multiple subscribers with the same, that share a subscription. So if you want to have several aggregates, so that one of them gets the new events, so to share the load. So if you have a stored projection in a database, for example, you would probably want to share the load between different aggregators, and read the current state, apply the event, and push the current state again. But you could also have cloud functions that are triggered by a new event. Then it will be pushed. Then you will have a bridge that pushes it into AWS, it's called SQS, or into Google Cloud's PubSub, so that it can trigger a cloud function or a Lambda directly.
When the user interface adds a comment, does it first do the write command, wait for a response that it was successful, and then make a read and then updates it, or do you get back the written answer?
If you do a proper segregation of commands and query, you do not get back, you just get a 204 accepted. But the front end, in most cases, the front end should know what it's added and be able to deduct that. For a commenting system specifically, you would probably have an open socket anyway, getting events about new comments. So you would get it as an event and not do a get query afterwards. So you can have bridges, like pushing some of these events in a curated format all the way to the front end. And that's also one of the gains, I would say, of event sourcing. You know that everything that happens exists as an event. So you can have listeners acting on these events. In many cases, I've seen places that use events for a lot of things, but the events are made after the actual data change, which means that when something is developed, you add the event as an afterthought, and sometimes, well, you go on to the next thing instead of putting the time into writing the proper audit log, for example. When I was working at Auth0, the audit log was very important because it's an authentication and identity management platform. But still, it was added as an afterthought. We changed the MongoDB state, and then if we were in a hurry, we didn't add the audit log for that particular thing, and then we went to the next thing. Just having a task in our backlog saying, oh, we should add the audit log as well. So editing events or audit logging as an afterthought often gets deprioritized. Yeah, my screensaver is a good organization. So in my experience, having event sourcing is the only way to know that you actually store all the changes.
Is there like a prepackaged sort of service you can run like Postgres or using an event store that isn't tied to any of the big cloud providers?
Yeah, so event store, the event store called Event Store, you can run that as a Docker. It is open source.
It doesn't have the optimistic concurrency.
Yeah, that has the optimistic concurrency and the user interface. And it has also very good high-speed handling of the events. You can handle a lot of events and make a lot of streams, because the streams are cheap. Just like when Git came, that branches got cheap. Before in CVS, when you branched, you got a full copy of the whole state. So yeah, I would highly recommend checking out eventstore.com. I'm not affiliated with them in any way. Okay.
Are you using this at Void?
We are using this at Void for the new system. So like Anders described, I'm one of the ones that came in and got to do the fun things to replace the old deprecated backend. And we are using this heavily with a lot of microservices and cloud functions.
How is the developer experience on your local machine when you have all these micro components? Is it hard to get up the whole system?
It needs some initial setup, but if you handle Docker and you have a small runner for the cloud functions, it's quite simple in the end. But you need to have the Docker app. So with Docker, we are running the event store and the other things that needed around it, and the express gateway that will route, so you get a local running of it. So yeah, it's some extra initial setup than if you just have a monolith. But after that, it is really nice to just add more and more services. Like, I think I was listening to Microservices talk by Netflix, and they said that the first 50, they are hard. But then you have the boilerplate, and you have the CI system to take care of everything, and then you're kind of used to adding new. So now when I add a new service, and it should answer some HTTP queries, I just add that in the OpenAPI specification, and it gets routed pretty much.
And maybe you don't run everything at once all the time.
No, normally you don't need to, but so far we can run all at once. It brings up all the Docker services and all the cloud functions.
I have another question. How do you manage the disaster recovery procedure for the event store in case by somebody gets corrupt or you have some other problems with it?
Normally, when you run in production an event store, you run a cluster with several at the same time, so you shouldn't have, but of course you have backup procedures as well with event store. And you can restore backup if you would get a really bad shape. As backups go, you always lose some data. And you need to go to the ops guys and ask them to untar. Thank you.
Yeah, thank you very much. Thank you, Anders and Boyd, for sponsoring. If your company wants to sponsor our way, just talk to me. And if you want to talk, you don't come to talk to me. I don't know if the door is open.